All right, in this video we're going to be looking at the second part of lesson 211. Now this is officially the part of the chapter that we're in. Now if you did not watch the previous video where we learned about how to solve a system of equations using matrices, I highly recommend going back and doing that because that's something that we're going to use in this lesson to make things a lot easier. All right, so first off, what is partial fraction decomposition? Well, let's actually go back to what we did at the beginning of this chapter. So there was problems. In fact, this is one that was directly out of your homework assignment, and where we gave you a problem like this, okay, where we had to get the denominator in factored form, and then once we got it in factored form, we wanted to combine it and write it as a single fraction. And so when you wrote it as a single fraction, this was your answer. Well, what if instead of starting with the original problem where we had two separate fractions, what if I gave you this x squared plus 9x plus 10 over 2 times the quantity x plus 5x plus 5 or x plus 5 squared, and asked you to break it apart into two separate fractions where we would get the original problem? How would we go about working our way backwards, essentially? Well, that's what partial fraction decomposition is all about. And there's actually three cases, meaning, or not three cases, five cases that we could look at. And in this video, we're just going to look at this first case where we have all linear, non-repeating factors. What does that mean? Well, let's look at this first example. So when we say all linear, non-repeating factors, that's referring to the denominator. So the denominator here, we have these three factors, x, x minus 7, and x plus 8. All three of those factors are linear factors, okay? And non-repeating, meaning that we don't have like x minus 7 squared or x minus 7 times x minus 7. All right, so if we're dealing with all linear factors and none are repeating, the first step is we're going to set up a separate fraction for each factor in the denominator and use a distinct variable for each numerator. All right, so that sounds complicated, but really it's just this simple. Let me show you. So we're going to start with our first denominator being x. And let's just put a value in the numerator, like a. You can use any variable you want, but let's use something different from x, y, and z if that's what we're dealing with in our equation. So use a variable that's going to be different enough from the variables that are in our equation to keep them separate. All right, so then we're going to have another fraction for this one where we have x minus 7 in the denominator. Again, give it a different variable in the numerator. And then let's look at the denominator with x plus 8. Again, pick a different numerator. And we're going to set that equal to the original fraction. All right. So to simplify this, what we're going to do is we're going to multiply every term by the least common denominator and solve the resulting equation for a, b, and c. So the least common denominator in this case is what we had in our original fraction, x times x minus 7 times x plus 8. So we're going to multiply every term by the LCD and solve the resulting equation. So let's see how that works. Okay, so when I multiply by x times x minus 7 times x plus 8, again, we're going to do that times everything here. So that first term with the a, since the a has the x in the denominator, those would cancel each other out, leaving us with x minus 7 times x plus 8. Okay, now let's go to the fraction with the b in the numerator. So the fraction with a b in the numerator already has an x minus 7 in the denominator. So those two would cancel out, leaving us with x times x plus 8. All right, so now let's look at the one with c in the numerator. That has x plus 8 in the denominator. So that x plus 8 and the x plus 8 from the least common denominator, those would cancel each other out, leaving us with x times x minus 7. And remember, we're going to multiply everything, including the right side. So when we multiply that times our least common denominator, they have all 3 in common. So they're going to cancel out. So all we're left with on the right side is negative x squared plus 30x minus 56. All right, so the next step we're going to do is we are going to simplify these. So this first one is going to be the worst to simplify. So let's multiply those together. So x minus 7 times x plus 8. If you want to take the take up space and use the box method, you can. Otherwise, we can just use that extended distributive property. So x times x is x squared. X times 8 is 8x, but I'm going to hold on to that. I'm going to remember that in my head because the next term is going to be the like term. So we'd have negative 7x comes next. So x times 8 is 8x, and then negative 7 times x is negative 7x. Add those together, we just get x. And negative 7 times 8 is negative 56. I'm just going to go ahead and do the next step. I'm going to distribute a through, in which case we get ax squared plus ax minus 56a. All right, with the next one, I can look at this as being bx instead of b times x. We can really need that parentheses, but if we multiply, if we distribute the bx through, oops, I do it down here, we would get bx squared plus 8bx. Do the same thing with the cx, distribute that through, we would get c, not 6. There we go. We get cx squared minus 7cx. And that's equal to negative x squared plus 30x minus 56. All right, I'm running out of space here, so I'm going to go on to a different slide. All right, so I have that ready for me here. All right, so this is that same expression that we just had. Okay, now there's a lot of garbage here. So we're going to organize this into a system of 3 equations. We're going to start with our first equation just being the x squared equation. Okay, so we're going to have ax squared plus bx squared plus cx squared equals negative 1x squared. Okay, then we're going to write down our just single variable equation. So that would be ax plus 8bx, and then minus 7cx. And that's going to equal 30x. So all of those, which is a single variable x that I double underlined, that would be our single variable x equation. And then we're going to have our equation for our constants. Now, if you notice, we only have these 2 constants. So we would have, and let's line this up. So if you look at our equations, we have the first terms are a terms, our second terms are b terms, and our third terms are c terms. And if you notice, the negative 56a, that's an a term. So we're going to put that way over here. So we negative 56a equals, and we have negative 56. All right, so what we're going to do now is we need to figure out what our values for a, b, and c would be. Now, if we wanted to, we could pretty easily figure out what a is by just dividing both sides by negative 56 to get that value. Otherwise, we could use matrices. Let me show you how we would use matrices. So instead of doing it the long way, we'd first find a, then find b, then find c. Let's create a matrix. So remember, we talked about that in the previous video, where we would have our coefficient matrix. We call that A. Actually, before we go any further, let's just review that process. So if we call the coefficient matrix A, which again is a little bit confusing because we have the A, B, and C here, but just remember we have the coefficient matrix times a variable like x, so like our variable, equals our constant matrix. And so if we wanted to solve for x, remember we take the inverse of both sides, because if I take the inverse of that matrix and multiply it times the inverse of that one, we would get x equals the inverse of our constant matrix times, or our coefficient matrix times our constant matrix. So that's how we're going to set it up. Okay, so let's just review. And if that was confusing to you, that's why I said earlier, make sure you watch that previous video so this makes a little bit more sense. All right, so let's write down those coefficients. So here we would have a lot of coefficients that would have just 1. So across the top, we would have 1, 1, and 1. And then the next row, we would have 1, 8, and negative 7. The bottom row, we have negative 56. And the other ones, we don't have any values. We would just put in as zeros. So we're going to take the inverse of that one and multiply it times a constant matrix, which would be negative 1, 30, and negative 56. And whatever that gives us, that's going to be our A, our B, and our C values. So that's what we need to find. All right, so let's review how to do that on your graphing calculators. Remember, the secret axis to be able to get to matrices, you're not going to see it up here, but if we do alpha and then zoom, that gives us this option to create a matrix. And so now we know we want to make a 3 by 3 matrix that's labeled rows by columns. All right, so in that first, we're going to go across by rows. So in that first matrix, we would have 1, 1, 1. Keep hitting the right arrow to go to the next row, and we would have 1, 8, and then negative 7. Make sure you don't use a minus sign. Use the negative symbol, which is next to the enter button. So 1, 8, and negative 7. The right arrow to go to the last row, and this would be negative 56. So do the negative again, 56, and then 0, 0. So we can just leave those. Okay, so then we arrow out of the matrix, and then we're going to use our inverse button. And we can do times, and then we're going to do alpha zoom again. And this time this is going to be 3 rows, but 1 column. And in that column, we're going to do negative 1. Hit the right or down button in this case, and then 30, and then negative 56 again. Arrow out of it, make sure you got everything correct, hit enter, and you should get 1, 1, and negative 3. All right, so now we know our A values for A, B, and C. Remember that was in the numerator. So if we go back, and so if we, let's actually go back to this so we can see the original format. So I'm going to put that to the right here. So remember our A value is 1, so we'd have 1 over x. Plus, and then we found our B value to be 1, so it'd be 1 over x minus 7. Plus, and then our C value was negative 3, so we'd have negative 3 over x plus 8. So these two equal each other. So if we were given 1 over x plus 1 over x minus 7 plus negative 3 over x plus 8 and use a least common denominator to simplify it as a single fraction, we would get what we had there in blue. All right, so remember the process. Look at that slide. Look over your notes. Pause it if you need to. Let's do one more together. Let's look at this one. So this one's a little different. So this one, we have the denominator is not in factored form. So let's get this in factored form first. So we're going to do that by looking to see what two values multiply together to be negative 2, that add together to be negative 1, that'd be negative 2, and positive 1. All right, so now we have the denominator in factored form. So remember what we're going to do next is we are going to set up a bunch of fractions using the individual factors as our denominators. So I'm going to have a over x minus 2 plus b over x plus 1. And that's going to equal the original equation, which was 3x minus 3 over x minus 2 times x plus 1. All right, so remember the next step is to use a least common denominator. So the least common denominator here is x minus 2 times x plus 1. So for the first fraction, we would have a times, so the first fraction has x minus 2 in the denominator already, so we'll be left with x plus 1 after those two cancel each other out. And then in the second fraction, the b has x plus 1 in the denominator already, So those would cancel each other out, leaving us with b times x minus 2. And then on the right side, we're going to multiply by the least common denominator. The denominators would cancel or the denominator would cancel out, leaving us with 3x minus 3 on the right. All right, so let's just go ahead and simplify this. So when you do that, you get ax plus a plus bx minus 2b equals 3x minus 3. Now this time when we set this up as a system of equations, we only have two variables. I'm sorry, we only have just the single variable. We don't have an x squared here like we did in the previous one. So this one's actually going to be a little bit easier. So when we set up our equations, I'll do that over here. When we set up our equations, we would have ax plus bx equals 3x. And then our other equation for just the constants, where we don't have a variable, we would have a minus 2b equals negative 3. And so when we go to use matrices to simplify this, our coefficient matrix would be, we would have 1 for all those three. So we would have 1, 1, 1, negative 2. We're going to take the inverse of that and multiply that times the constant matrix, which would just be the 3 and the negative 3. All right. Now this time when you go to do this on your calculators, we're going to set it up as a 2 by 2 matrix. Whoops. So do alpha zoom. Like I said, we're going to do it as a 2 by 2 matrix. And so those numbers were going across the top, 1, 1, 1, and negative 2. Move it outside, take the inverse, do that times, then do alpha zoom again. Whoops. And set it up as a 2 by 1. So we just have one column. And in that column, we had 3 and negative 3. All right, hit enter, and we get our a value is 1, our b value is 2. So let's go back to our notes. So again, those are our a and b values. So our equation, if we were to plug those in for a and b, that's what we want to do. It'd be 1 over that first factor, x minus 2, plus 2 over that second factor, x plus 1. So that's the answer that we are looking for. All right, so it's not too difficult. It's a process. So I want you guys to try one on your own. So you guys are going to try this one. So go ahead, pause the video, and hit play when you're ready to check to see how you did. All right, let's see how you did here. So to start out with, make sure you factored it correctly. So you should have factored it what I have in yellow, x minus 4 times x plus 1. All right, so if you did that correct, then the next thing you would do is take those two factors in the denominator, separate them out using different letters in the numerators. So we would have a over x minus 4 and b over x plus 1 equals the original fraction, which is 3x minus 37 over x minus 4 and x plus 1, which is also your least common denominator. So when you multiply that first fraction by your least common denominator, you're left with x plus 1. So we'd have a times x plus 1. And the second term, when you multiply that times the LCD, you're left with b times x minus 4. Then the right side, you get rid of the fraction, so we just have 3x minus 37 on the right. So when we simplify, we get, I have in the bottom there in green, ax plus a plus bx minus 4b equals 3x minus 37. So set up your system of equations, starting with just your variables. So we would have, by variables, I mean your x's. So we'd have ax plus bx equals 3x. And then to go to our constants, the numbers, or in this case, letters that do not have a variable x attached to it. So we'd have a negative 4b equals, or a minus 4b equals negative 37. So you get what's over there in blue. So then set up your matrices, take the inverse, and simplify, get your answer. You get negative 5 and 8. So your a value is negative 5 and your b value is 8. So hopefully that makes sense. And so, like I said, this is just one case out of 5. And so these are all the different possible cases. So we could have repeated linear factors in the denominator. So that would look like something where we would have x minus 3 squared times x plus 2 or something like that. And then a bunch of stuff in the numerator. We could have one irreducible quadratic factor. So if we had x squared, I want to make sure this wouldn't factor. If I had 3x squared minus 5x plus 13, that can't factor, so that would be one irreducible quadratic factor. We could have repeated irreducible quadratic factors. That's just where we would have something like that in the denominator, where it would be squared. And then we could have more than one irreducible quadratic factor. That's where we would have something like, 3x squared minus 5x plus 13 times another irreducible quadratic. Okay, so that's what they mean by those different cases. And so we're only going to focus on just this first one, where we just had a single linear, non-repeated factor in the denominator. So good luck now as you work on your assignment.